Example 12.1 Part D will be the last part here for example 12.1, working on converting from standard form into the vertex form. And I've saved the most challenging example for last. In this example, we have our standard form where A is 3, B is 2, and C is equal to -2. And if you copy down example 12.1c and understood what was going on there, you can use that as a means of reference to be able to mimic the process that we're going through here, because it's going to be the exact same process. The only thing that's going to be, say, slightly different is that we're going to end up having to deal with some fractions here that we didn't have to do in any of the other examples. And you might be saying, I don't see any fractions. Well, just wait. There's going to be some fractions that appear. So on part C, we saw that we need to use the first two terms to factor out the 3, which is what the a value is, because the idea is that we want the a value to be a 1 as the coefficient for the x squared. So if we factor out 3, we can make that happen. So f of x is going to equal 3 times, so certainly 3 multiplied with x squared is going to give me 3x squared. But the harder part is, what am I going to multiply 3 with to be able to get back to 2x? And this is where a fraction ends up showing up, because you're going to have to multiply 3 with 2/3 x in order for it to come out to be 2x. So you do have to be comfortable with multiplication, whole numbers, fractions, in order for this to work out properly. I'll also tack on the subtraction of 2. So now the statements are 100% equivalent. Next, I want to look at the creative 0 step. So for the creative 0, I'm going to be taking 2/3 and dividing it by 2, and then squaring that result. So I never try to actually divide a fraction by a whole number or by another fraction, but instead, if I'm supposed to be taking 2/3 and dividing it by 2, I would rather multiply by 1/2. So there's that nice trick there that we've seen before. So when I multiply 2/3 by 1/2, I'm going to end up getting 1/3, and then 1/3 squared is just going to be 1/9. So that becomes my creative 0 value. So f of x will equal 3 times x squared plus 2/3 x plus 1/9 minus 1/9, close the parenthesis, and then put in the -2. So that takes care of our creative 0. Let's go ahead and group together the first 3 terms in the parenthesis, and believe it or not, it does form a perfect square trinomial. The factoring is going to end up being x plus 1/3 squared, and then I still have the minus 1/9, close the parenthesis, and bring down the -2. So one of the details that was mentioned in a previous part of this example was the fact that right before you do your squaring, we have 1/3. That ends up being the value that shows up in your factoring of your perfect square trinomial. So if you ever come across something like this again and you don't remember how to do the factoring, this will give you a clue as to what that factor needs to look like. But you still have to have some understanding of trinomial factoring, but this will give you a big help getting in the right direction there. And now I need to distribute the 3 back into this big parenthesis. So I would have f of x is 3 times x plus 1/3 squared minus 1/3 minus 2. Final step will be to combine the constants at the end. 3 times x plus 1/3 squared minus 7/3. And that represents the vertex form for f of x. And we can also say that a is still equal to 3, h is now negative 1/3, and k is negative 7/3. So we get the vertex location at the ordered pair negative 1/3, comma negative 7/3. And that completes example 12.1, part D.